Welcome! I am Teacher M. This tutorial video is focused on finding the derivative of a radical function using definition of derivative. If you're interested, stay and watch the entire video. First example, what is the derivative of square root of x? Derivative is equal to the limit of g of x plus delta x minus g of x over delta x as delta x approaches 0. Like what we did on the previous videos in finding derivative of function, let's find g of x plus delta x and g of x separately. G of x is the given function, which is the square root of x. G of x plus delta x is equal to the square root of x plus delta x. Substitute this to the definition of derivative. Limit of g of x plus delta x, which is square root of x plus delta x, minus g of x, which is square root of x over delta x as delta x approaches 0. Observe that when the limit is applied in the denominator, it will be 0 and the whole expression will be undefined. In this case, we need to eliminate delta x before applying the limit. The question here is, how can we eliminate delta x? Unlike in the previous videos, the numerator here is not factorable. What can we do to manipulate the expression? In this example, let's rationalize the numerator. To rationalize the numerator, multiply it by the conjugate of the numerator. The conjugate of the numerator is square root of x plus delta x plus square root of x. A piece of advice: before continuing watching this video, review first how to find the conjugate. A conjugate video tutorial will be tackled in this channel soon. Going back, multiply also the conjugate to the denominator. Get the product? The product of the numerator and its conjugate is a special case of multiplication, which is sum and difference of binomial. Thus, we can easily get the product by squaring each term and separate it by subtraction. Limit of square root of x plus delta x minus the square root of x over delta x multiplied to the conjugate. Get the square of each term. We have the limit of square root of x plus delta x is simply x plus delta x minus to the square root of x is x over the whole denominator. Combine similar terms in numerator. X minus x is 0. Limit of the remaining term in numerator, which is delta x over the whole denominator. We can now eliminate delta x by dividing it by delta x. Simplify. Limit of 1 over sum of the square root of x plus delta x and square root of x as delta x approaches 0. Apply limit property. Limit of numerator over limit of denominator as x approaches 0. Continue to apply limit property in denominator. Rewrite numerator over the limit of square root of x plus delta x as delta x approaches 0 plus limit of square root of x as delta x approaches 0. Apply limit property to the first term of the denominator, which is the limit of square root of x plus delta x. Rewrite the numerator over the square root of the limit of the sum of x and delta x as delta x approaches 0 plus the second term. In the same term, continue to apply limit property. Numerator over the square root of limit of x as delta x approaches 0 plus limit of delta x as delta x approaches 0 plus the second term. Get the limit of each term, and it is equal to 1 over square root of x plus 0 plus square root of x. Simplify. 1 over the sum of square root of x and square root of x. Combine terms. Then the derivative of the function is 1 over 2 square root of x. Using this derivative, we can now calculate the slope of the function at every point on it. Example, what is the slope of the function at 1/4 and 1/2? Before we proceed in solving the slope of the function, let's make it clear the output of a function and output of a derivative. Function is a system of input and output. Input is the x-coordinate or domain, and the output when you substitute the x-coordinate to the function is the y-coordinate or range. Derivative of function is also a function that has input and output. Input is x-coordinate or our domain, and the output is the slope of the function. Thus, the original function gives you the y-coordinate while the derivative gives you the slope of the function. To solve the derivative of the function at a given point, substitute x-coordinate to the derivative. G prime of 1/4 is equal to 1 over 2 multiplied to square root of 1/4. Simplify. 1 over 2 multiplied to the square root of 1/4, which is 1/2. Simplify it further. The denominator will be 1. Thus, the slope of the function at 1/4 and 1/2 is 1. On the same point, find the equation of the tangent line to the function at x is equal to negative 1/4. Similar to other videos, to find the equation of the line, use point-slope form. Substitute values. Y minus y-coordinate, which is 1/2, is equal to the slope, which is 1, multiplied to x minus the x-coordinate, which is 1/4. Distribute 1 to each term of x minus 1/4. We have 1 minus 1/2 is equal to x minus 1/4. Add 1/2 to both sides of the equation. Y equal to x minus 1/4 plus 1/2. Combine fraction. It is simplified to 1 is equal to x plus 1/4. The equation of the tangent line on the function at 1/4 and 1/2 is y is equal to x plus 1/4. Another example. What is the derivative of h of x is equal to square root of 2x minus 1? The derivative is equal to the limit of h of x plus delta x minus h of x over delta x as delta x approaches 0. Find h of x and h of x plus delta x. H of x is square root of 2x minus 1. And h of x plus delta x is square root of 2 multiplied to x plus delta x subtracted to 1. Distribute 2 to each term of x plus delta x. And it is equal to square root of 2x plus 2 delta x minus 1. Then substitute each of x plus delta x and each of x to the definition of derivative. Limit of h of x plus delta x, which is square root of 2x plus 2 delta x minus 1, subtract 2 h of x, which is square root of 2x minus 1, all over delta x as delta x approaches 0. Similar to the previous example, rationalize numerator. The conjugate of the numerator is the square root of 2x plus 2 delta x minus 1 plus the square root of 2x minus 1. Multiply this conjugate to numerator and denominator. Get the product. Limit of the square root of 2x plus 2 delta x minus 1 subtracted to the square root of 2x minus 1 all over the product of delta x and the conjugate as delta x approaches 0. Find the square of each term. Then, the limit of the square root of 2x plus 2 delta x minus 1 is simply 2x plus 2 delta x minus 1 subtracted to the square root of 2x minus 1 is 2x minus 1 all over the entire denominator as delta x approaches 0. Remove grouping symbols. We have limit of 2x plus 2 delta x minus 1 minus 2x plus 1 all over the whole denominator as delta x approaches 0. Combine similar terms. 2x minus 2x is 0 and negative 1 plus 1 is 0. Limit of the remaining term in numerator, which is 2 delta x over the entire denominator as delta x approaches 0. Eliminate delta x. Limit of 2 over the sum of square root of 2x plus 2 delta x minus 1 and square root of 2x minus 1 as delta x approaches 0. Apply limit property. Limit of the numerator as delta x approaches 0 and limit of the denominator as delta x approaches 0. Continue. Rewrite the numerator over the limit of square root of 2x plus 2 delta x minus 1 as delta x approaches 0 added to the limit of square root of 2x minus 1 as delta x approaches 0. Rewrite again the numerator and apply limit property to the denominator, which is the square root of the limit of 2x plus 2 delta x minus 1 as delta x approaches 0 added to the square root of limit of 2x minus 1 as delta x approaches 0. Rewrite the entire numerator over the square root of the limit of 2x as delta x approaches 0 plus the limit of 2 delta x as delta x approaches 0 minus limit of 1 as delta x approaches 0 added to the square root of the limit of 2x as delta x approaches 0 minus limit of 1 as delta x approaches 0. Get the limit of each term and it is equal to 2 over the square root of 2x plus 2 times 0 minus 1 added to the square root of 2x minus 1. Simplify. Equal to 2 over the sum of square root of 2x minus 1 and square root of 2x minus 1. Combine similar terms and it is equal to 2 over 2 square root of 2x minus 1. Get the lowest term? The derivative of the function is equal to 1 over the square root of 2x minus 1. This derivative represents slope at every point on the function. Find the slope of the function at 1, 1. On the graph of the function, this is the point where we want to find the slope of the function. To find the slope, substitute x coordinate to the derivative. We have h prime of 1 is equal to 1 over square root of 2 times 1 minus 1. Simplify. It is equal to 1 over the square root of 2 minus 1. Simplify it further. The slope of the function at 1, 1 is 1. On the same point, find an equation of the tangent line to the function at 1, 1. Substitute values on point slope form. We have 1 minus y coordinate, which is 1, is equal to the slope, which is 1, multiplied to x minus x coordinate, which is 1. Simplify. Y minus 1 is equal to x minus 1. Add 1 to both sides of the equation. Then, the tangent line to the function at exactly 1, 1 is y is equal to x. The graph shows the tangent line on the graph at 1, 1, and its equation is y is equal to x. Last example. What is the derivative of cube root of x? F prime of x is equal to the limit of f of x plus delta x minus f of x over delta x as delta x approaches 0. F of x is cube root of x, and f of x plus delta x is the cube root of x plus delta x. Substitute each on the definition of derivative. Limit of f of x plus delta x, which is the cube root of x plus delta x, minus f of x, which is the cube root of x over delta x as delta x approaches 0. Same procedure will be applied here. Rationalize the numerator. The conjugate of the cube root of x plus delta x minus cube root of x is the square of the cube root of the sum of x and delta x plus the product of the cube root of the sum of x and delta x and cube root of x plus the square of the cube root of x. If you are interested to learn more about conjugate, stay tuned in our channel to be updated in future math tutorials. Multiply the conjugate to numerator and denominator. Get the product of the numerator and the conjugate. The numerator and the conjugate is a special product that the product can be found easily. The product is simply the cube of the first term minus the cube of the second term over the product of delta x and the conjugate. Get the cube of each term. We have limit of cube root of x plus delta x, which is simply x plus delta x, minus cube root of x is x over the entire denominator. Combine similar terms. X minus x is 0. Then, limit of the remaining term, which is delta x, over the whole denominator. Eliminate delta x. We have limit of 1 over the remaining factor of the denominator as delta x approaches 0. Apply limit property. Limit of the numerator as delta x approaches 0 over limit of the denominator as delta x approaches 0. Rewrite numerator and apply limit properties in denominator. Limit of the first term as delta x approaches 0 plus limit of the second term as delta x approaches 0 plus limit of the third term as delta x approaches 0. Continue to apply limit property in denominator. Rewrite the numerator over square of the limit of cube root of x plus delta x as delta x approaches 0 plus limit of cube root of x plus delta x as delta x approaches 0 times the limit of the cube root of x as x approaches 0 plus the square of the limit of cube root of x as delta x approaches 0. Apply radical property of limit. Rewrite numerator over square of cube root of the limit of x plus delta x as delta x approaches 0 plus cube root of the limit of x plus delta x as delta x approaches 0 multiplied to the cube root of the limit of x as delta x approaches 0 plus the square of the cube root of limit of x as x approaches 0. Apply sum and difference property of a limit to the first term and first factor of the second term of the denominator. Rewrite the numerator over square of the cube root of the limit of x as x approaches 0 plus limit of delta x as delta x approaches 0 plus the cube root of the limit of x as delta x approaches 0 plus limit of delta x as delta x approaches 0 multiply to the second factor plus the third term. Get the limit? 1 over square of the cube root of sum of x and 0 plus cube root of the sum of x and 0 multiplied to the cube root of x and added to the square of the cube root of x. Simplify. 1 over square of cube root of x plus the product of cube root of x and cube root of x plus the square of the cube root of x. Simplify. Get the product of the second term of the denominator, which is the product of cube root of x and cube root of x, and it is equal to square of cube root of x. And rewrite the remaining terms. Simplify. It is equal to 1 over 3 square of cube root of x, or we can rewrite it as 1 over 3 cube root of x squared. This derivative allows us to find the slope of the function at every point. Next, find the slope of the function at x is equal to -1. On the graph, this is the point where we want to find the slope of the curve. Substitute the x coordinate to the derivative. We have f prime of -1 is equal to 1 over 3 cube root of square of -1. It is equal to 1 over 3 times the cube root of square of -1, which is equal to 1. Simplify. The slope of the curve at a specific point is 1/3. Then, find the tangent line on the curve at the same point. Use point-slope form to find the equation of the tangent line. In this example, y coordinate is unknown. To solve for y, substitute x coordinate to the function. We have f of negative 1 is equal to the cube root of negative 1. Take the cube root, the y coordinate is negative 1. Substitute all known in the point slope form. Y minus y coordinate, which is negative 1, is equal to the slope, which is 1/3, multiplied to x minus the x coordinate, which is negative 1. Simplify, we have y plus 1 equal to 1/3 multiplied to x plus 1. Distribute 1/3 to each term of x plus 1. And y plus 1 is equal to 1/3 plus 1/3. Subtract 1 to both sides of equation. We have y is equal to 1/3 x plus 1/3 minus y. Combine terms, and it is simplified to y is equal to 1/3 x minus 2/3. This is now the equation of the tangent line on the curve at x is equal to negative 1. And as you can see, it is also on the graph. There you have it. How to find the derivative of radical function. Next videos discuss the rules of derivative. If you learn on this video, don't forget to hit the like button and subscribe to be updated and notified for other math lessons. See you!